can
All
see
right, so
it.
my background, like Sheila said, I spent most of my working years working for Union Pacific Railroad. And then in the middle of all that, I went back and got a master's in structural geology from Idaho State and did my thesis there in southeast Idaho. And a lot of you folks that were on the Idaho field trip know Dave Rogers, and he was my instructor, as well as Carol Means is also on the call here. She was one of Dave was one of her instructors as well. Dave continues to do good work, mostly in the Yellowstone hotspot. A lot of the ideas on Yellowstone hotspot are his, and among others, but that's where he's focusing his research work. I'm going to talk a little bit about volcanoes here today, and I'll show you the reason why. These are the two volcanic arcs that are on the west coast of South and North America, respectively, and lots of reasons to compare them. The main reason that we're going to go into these is I visit both of these quite routinely. Part of what I've done since I've retired is work with my wife, Charlotte, who's leads this what we call Nueva Sonrisas dental team. We go down to Guatemala once a year. Actually, it's this week, it's first week of February, and work fixing the kids' teeth down there. And they're pretty much prior to you go back 50 years, their teeth were fine, and then we introduced them to our diet, and now all their teeth are rotten, and they don't brush their teeth. So I mean, we may or may not have some responsibility there, but we go down there, and I'm an engineer on the team, and this is one of the schools we go to, and this Volcan Suchatan is actually one of the it's a dormant volcano that's part of this Central America Volcanic Arc. After we get done working, we've spent a fair amount of time marching up some of these volcanoes. And so I've often asked myself, well, if they're active down here, I mean, there's 2 or 3 of them going off as we speak. And then I fly home to Portland and I look around and there's nothing going on up here. So I kind of asked myself, I said, well, what's going on? And so that's kind of the what this paper is about. And we'll talk a little bit about basics here. We've got a subduction zone off the coast of the west coast of Guatemala and Central America, as we do here. And there's lots of variability, lots of variables that affect subduction rate versus volcanic production rates. And these factors are, as I've done some of this research, has to do with how fast the 2 plates are converging. You got the lighter continental crust here versus the blue is the subducting oceanic plate that goes down underneath the continent. The angle of subduction has a lot to do with how prolific the volcanoes are produced. There's also an angle between the spreading center and the subduction zone. And probably one of the key factors I've discovered is it's the distance between where the spreading center, where this rock originates as ocean bottom, and then the time or the distance between where it becomes rock and then where it gets subducted underneath the continent. And then one of the factors too is how thick the continent is. And we'll go into those factors real quick. And here's one of the what I was just talking about. Here's the distance between the Juan de Fuca plate and the subduction zone underneath the west coast of Oregon here. It's roughly down here, it's about 100 miles off the coast, and up here it's about 250 miles. As opposed to out here in where we're talking about up here in or down here in Central America, where you go roughly from the Galapagos to the subduction zone, you're about 650 miles at that point. And what happens and why that's an important factor is this plate over here in the Juan de Fuca is relatively recently made, and it's basically the plate is fairly intact. It's not hydrated at all, so it doesn't have a lot of water incorporated into the rock structure, as opposed to if it's 400 to 500 miles off the coast. The heat is gone from its creation, and most of the rock has been deteriorated and hydrated with water. So it's one of the big factors in how many volcanoes are propagated from the subduction. The other key factor is this spreading rate. The Juan de Fuca plate's roughly about 1.5 to 2 inches a year going underneath our Oregon, as opposed to down here in Central America. You've got quite a much faster, roughly 3 times the subduction rate. So those are factors that enter into, at least in my mind, what was going on. So my thinking is I flew down to Guatemala, climbed these active volcanoes, and then came back and saw the dormant ones. Is well, okay, well, it's obvious. We're the subduction zone off the west coast here, the Juan de Fuca plate. It's a lot slower, therefore we have less volcanic activity. Does that make sense? So I figured, okay, I'm happy with that. And I called around and found one of my former professors there at Idaho State, Bill Hackett, and he says, "Yeah, I'll send you a paper that says exactly that." And I said, "Okay, well that's fine. I'm happy, and I can go forward with that." But the more I dug into what's going on, I realized it's not that simple. So we're just going to call this tonight's little lecture just a work in progress, and you'll see why when we get to the end here. Let's go back to the similarities. Again, both these plates, the Juan de Fuca plate and the Cocos plate, which is off the coast of Central America, were originally part of the one Farallon plate that subducted underneath the North American plate. And they basically impinged about 23 million years ago, and then that created the San Andreas fault system, which you guys all know about. And basically they took the Farallon plate and because that plate's now underneath North America, and then broke it into 2 plates, the Juan de Fuca and the Cocos plate. And as the San Andreas continues to do its subduction, its right lateral transform, these plates continue to be further and further apart, and you can see they have migrated quite a ways apart from where they hit the west coast about 20 million years ago. All right, that's one thing, and then the real other thing that gets into is just exactly what is a volcano, and most of you guys know that. Let's just go down to this second point. A lot of the stratovolcanoes versus the shield volcanoes, and are really strongly dependent on what kind of rock is coming out of what kind of magma is coming out of the vent. We're finding out that if you have a fast-moving rate and a steep subduction angle, you tend to get more volcanoes. And then the chemistry, as I said, is important as to whether you get a stratovolcano or an ash shield volcano. But then what comes out of that volcano is strongly dependent on the chemistry as well. So measuring volcano's volume is more an art than a science. I'll wrap this presentation up with a paper that just came out by Dan O'Hara out of the University of Oregon, and he's trying to put more science to this question. other factors that get into it is if you're right on the shoreline, if the winds blowing from the ocean to the shore, you're going to end up with more of the volcanic deposition onshore versus the other way around. If the prevailing wind's offshore, or if it's an island, you're going to end up with a lot of volcanic material down underneath the ocean, which you're going to then have to measure. You know, if you end up with an ash carapace up there, it's going to all blow away. We have north of Pocatello, we have Manan Buttes, and they've been very severely sculpted by the wind over the years. And so, you know, if you go to measure it, some of these that are affected by the wind, or in this case up in north part of North America, glaciation will be a big factor. We'll talk about that in a minute. But you know, you don't have much of a volcano left after a few years, and anybody that's been watching Nick Zentner, he's got a rule of thumb that generally a volcano is only going to be around for about 2 million years. The Quaternary is 2.6 million years, and so even more recent volcanoes, you know, I think that's the USGS's definition of whether it's active or not. If it's had an eruption in the Quaternary, then it's considered active. But as you can see, it would, if it's only going to be around for 2 million years, it'll disappear, I guess, before it can, even before the Quaternary's up. Anyway, rule of thumb that O'Hare has come up with is, and has very good data behind this, is that roughly if you can measure basically the edifice that constitutes a volcano, then roughly that's half of what's been erupted, is what he's saying. We go back to chemistry, and that has a lot to do with the silica content. And most of you folks know this gradation. When a magma column differentiates, you end up with the lighter material at the top, which is silica, and the more of the basaltic at the bottom here, you end up with more of the iron and the magnesium. So these are darker and these are lighter. But the big thing is really about the silicon tetraoxide, which is very much a grabby type ion molecule that will really make whatever flows out of or erupts out of a volcano a lot more pasty if it's got a lot of silica in it. So the silica content is really the determination of what, if you get a stratocone versus a shield volcano. So that's why that's important here. We'll start getting into some of these volcanoes, and they a few years ago they've basically listed a whole bunch of volcanoes around the world that they call them decade volcanoes. And there's 3 that we're going to talk about tonight that are on that list: in Colima down in Mexico, and the Mount Rainier you all know about, and then Santa Maria, which is in Guatemala. And then this one Taal volcano has since erupted since I put this together. So these are all, and Mount Etna's here is on there too. So a lot of these, and Merapi just erupted. So these are all the ones that folks are worried about, not just because of, well, it's because they're near large population centers is the key thing. Let's get into the Central America Volcanic Arc, and this is basically where we fly into Guatemala City here. If you look at the map on the left, and then we drive about 3.5 hours to where this star is, and that's where that volcano Suchitan is located. And we work there, and that really is on the migration trail from all the folks in Honduras and Salvador that are migrating up to the U.S. border. They all come right through there. They got hit by 2 hurricanes with about a week apart this past fall, and they're really in trouble down there. And so they're coming to knock on our door here. But this is the range of volcanoes. They're all very much in a line. You can see that when you're down there. We have a geologist friend of mine that's living about where on the A on Santa Maria. He lives in there. His name's Dave Stewart, and he's climbed a lot of these volcanoes. And I'll talk about Dave in a minute here. But these are basically all the volcanoes that we've gone to visit. And right in this Pacaya is one that's often climbed, and this Acatenango is another one. We'll talk about that, and then Atitlan. And so this is a tomography of the subducting plate underneath the continent of Central America. It's continental rock, and you can see it's a fairly steep angle that it's going, and it's subducting at 4.7 inches a year, which is quite fast. And so that's kind of the reason in my simple hypothesis as to why we've got a lot more volcanic activity down there in Central America. This whole talk is part travelogue, and so I'm gonna spend a few touristy type shots here. This is when we fly into Guatemala City, and this is the view you have. This is a plane landing right. The airport's just off to the left out of this picture, but this is a photo just right outside the window, and this is Agua, which overlooks Antigua, which is where we stay. This is Fuego, which is very much in the news lately. It's erupted, I think, 3 times, fairly significant eruption this month alone. And this one's a Acatenango, which is the one that you can climb. This is up to 13,000 feet here. And then Pacaya is just off the photo here, and it's right right at the end of the runway. It's quite a ways away from the end of the runway, but if this is erupting at all, they cancel all the flights into Guatemala City, because you'd have to, when you take off the land, you have to go fairly near the active cone. This is a photo I took a couple of years ago. When you climb up to Acatenango, you're this close to Fuego, and it's roughly about a mile away. But this is a shot of where you camp on the side of Acatenango. So it's a fairly dramatic place to be. And then there's a lot of people that were up there when it erupted in June of 2018. I'll talk about that. This is where you camp. They've kind of carved off these little platforms for a few tents, and they're really this thin. You're up around 13,000 feet. It costs you $40, and they give you a little backpack. And there's basically 2 4,000 foot climbs. You climb up to here, the first 4,000 foot, and then you you sleep, and then they wake you up at 4 a.m. to hike to the top. And so that's the tour. They don't let you go over to Fuego. However, once you're up here, the guides all come to you and say, if you want, give me about 200 quetzales, which is about $14. We'll take you on over. So they don't hesitate, really. The reason we didn't go, particularly because our group was very, very slow, and we got up there before the the time that we would have been able to get over there and get back before dark, so we didn't go. This is basically what it looks like when the sun sets. This is the Pacific Ocean over here on the right. It's pretty dramatic. So if you guys want to go see an active volcano at a fairly safe and moderate way of doing it, I would recommend doing that down here. This is we got up at 4 in the morning, and then we started walking up. This is the dawn next morning, and then we're walking up the volcano, up the scree. And this is where we landed, Guatemala City, and this is pretty much where we stay in Antigua over here. And you see the glow from the eruptive center there at Pacaya, and that's basically that's a very active volcano. And this is Agua, which is dormant. The reason this is called the water volcano, or volcano of water, is it had a large crater lake up here, and that basically in the 1500s, the Spanish basically set up this town here in Old Antigua, and the lava or the crater lake broke, and all that water rushed down and wiped out this town completely. And so the Spanish folks moved it over here to this new site in Antigua. So, and then this site has since been rebuilt. I don't think there's a lava or a water lake up there anymore, but that's how this volcano got its name. This is again looking at Agua, and then looking at Pacaya that was glowing in the night. And then Suchitan is one of these volcanoes out here that we do our dental work at. That's a picture taken about 4 a.m. And then finally you get up about 6 a.m. to the top, and it was really cold. And this is as close as you can be to Fuego. All right, so there are a lot of people up here when this thing erupted in June of 18, and they said it was pretty scary for obvious reasons. And this is a very, very active volcano. It's really, when you're down in Antigua, it's always going off. So it's very interesting to watch. And then you can get some feed from the internet, and basically, like I said, it's had 2 or 3 fairly major eruptions just this month alone, and I get those on the webpage all the time. But this is the one that really concerned everybody. This is the one in the USGS, which has a partnership with the Guatemalan volcanic or the geologic survey down there. They basically told these folks down there that this thing was going to go, and the you know, you always kind of hate this for this to happen, but the guy in charge of letting everybody know decided it was just a false alarm, and so he didn't do anything. Then that was at 6 in the morning, and then this is the basically about noon is when actually about 10 a.m. he started getting worried because this thing was really starting to move a lot of seismographs. And so this gentleman went running out there to see if he can start warning everybody, but by then it was too late. And this thing erupted at noon, and it had a pyroclastic flow that came down here and wiped out a couple of these little towns, these little yellow things down here. And including one of the persons that died was the director of the Guatemalan Volcanic Survey that was supposed to be announcing it to everybody, but he got covered or buried by the pyroclastic flow. Very unfortunate. The other volcano that you can climb is Pacaya, and this thing is definitely ready to go as well. This is the view from the end of the runway. And you can anybody can go up there, and they run 2 tours a day, and these travel guides, they come grab you out of the town square there in Antigua, and they take you up there, and they have a morning hike, climb up, and then basically an evening one. Basically we went up there at a time when used to go. This is a photo of my wife with Charlotte. With the we were up there when there was an electrical storm coming, and you could see her hair, which is sticking straight up. And there are lots of folks who are taking pictures of her because, well, not only was it was spectacular in terms of the electricity. It was the kind of electricity that you could rub your fingers together and the sparks would be coming off the tips of your fingers. And so I was pretty worried about that. I was less worried about the volcano, which was right here. I mean, you could step right, take one step, and you step over the edge and get a whiff of the sulfur dioxide. It was pretty darn strong. So, and the rocks up there were extremely hot. And if you left your feet sitting on one rock long enough, it'd start burning the leather. So you had to keep moving around. This is in 2004. I didn't go on this trip, but Charlotte did, and was able to see a lava flow. So I was pretty jealous of that particular trip. And here comes the lava down there. And in 2010, they basically had an eruption that killed a guide and a tourist. And so they don't let you go to the top anymore. So they only, let's see if I got a picture of it. Yeah. Oh, right here is this is where they used to let you go up the top. You'd go up this flank here, but now this is as high as you can go. And there's a fumarole there that the guides bring a package of marshmallows and some sticks, and so you can roast the marshmallows there by this fumarole. It's a lot easier hike there. It's only about 1,500 feet up. So those are the two active volcanoes. The other place that's just north of here, and these are all fairly dormant, but there's three volcanoes around here, four volcanoes. There's one just off to the left of the picture here, but there's two volcanoes here, Toloman and Atitlan, and just off the picture here, there's San Pedro. And this whole Lake Atitlan is one of the more beautiful places on Earth. It's the center of the Mayan culture. It's quite deep, and in terms of it's similar in depth to not as deep as Crater Lake, but it's quite much bigger than Crater Lake. And so all these communities around the lake, there's about 12 to 15 little Mayan communities that are set up here, and you can go visit each one of those on a motorboat. And Aldo Huxley, back in the 1880s or so, he said this is the most beautiful place on earth, and I have to agree. So if you do make your way down to Guatemala, you want to spend time in Antigua and then run up here to Lake Atitlan and just hang out for a week. Just north of here is a volcano, Santa Maria, which erupted in 1902. You'll see this 1902 repeated 2 or 3 times here, but you're standing, this picture was taken from the top of Santa Maria. I didn't take this one, but since 1902, this whole package of 4 volcanoes, Caliente, Matan, Monet, and Bruno, all have erupted. And this friend of mine, Dave Stewart, that I talked about, he's climbed most of these volcanoes, including Santa Maria. He won't go down in here. He says this thing is an accident waiting to happen. This thing is going to go off in any time. So it's prohibited to go there. But he says even if a guide tried to shoehorn you in there and take you in there, he wouldn't go. He says this is way too dangerous. So watch for that. That's considered one of the decade volcanoes as well, one of the ones that's ready to go. It's right next to a huge town called Quetzaltenango. Anyway, that's just the end of the tour in Guatemala. We'll now go down through El Salvador and Nicaragua and Costa Rica, volcanoes that we've visited. Total active volcanoes in Central America is about 82 volcanoes. And that compares with 15 up here in the Cascades, just to give you a number. And the average distance between them is about 17 kilometers. They're all fairly close to each other. So lots going on. This is a picture of Messiah. We were down there in 2006. This one was simmering then, and it's since erupted. It formed a lava lake down in there. So that's kind of roared back into life. And there's 2 or 3 in Nicaragua that are pretty active. This is Lake Nicaragua, and there's these 2 islands are called Omepete, and I recommend you go to these islands when you go to Nicaragua. There's a boat that takes you out to here to this island, and then you can stay on this island, or you can come over here. We stayed over on Madeiras, and we never did climb it, but there's a lot of people that do, and both these volcanoes are. This is just an amazing place to hang out for a week or so. Costa Rica's got RNL, which is very active, as well as Iratsu, and then the one right next to it, Turrialba, was they wouldn't let you go up there because that's very active as well. That's it for Central America. I'll just touch briefly on Mexico, and as this is all part of the what they call the Trans-Mexico Volcanic Belt, in this red oval. There's about 48 volcanoes down here. A little further apart, there are about 27 kilometers between volcanoes, and these are all pretty much east to west, all part of the Cocos Plate again, but different from Central America volcanoes. These are all big ones and active ones. This is the one Popocatépetl, which is active. That's actually erupted, I think, in November. A pretty sizable eruption. This one's somewhat dormant. Sleeping Woman, Iztaccíhuatl. Then Colima is a little further closer to the Pacific Ocean, and that's considered another decade volcano. And that's had a lot of eruptions, and that's probably erupting right now. Orizaba, Pico de Orizaba, I was down there working on a railroad, and this was the view we had every day, 18,000 feet or so, and it's over closer to Veracruz, but a lot of people climb this one. This is not active at all. So just to summarize what's going on down in Central America, you have roughly about 130 volcanoes, most off this Riviera Plate, and most of them are off this Cocos Plate. And there's Turrialba down in Costa Rica, which is erupting. I'm going to switch gears a little bit. So this Bill Hackett, my professor there in geology, I told him what the issue was. I said, well, I see all these volcanoes down in Central America going, and we have a heck of a fast subduction rate. And up here in the Cascades, we don't have much. So he referred me to this paper that basically says that. This is a guy, Wage, who talks about he compares the volcanoes in the Lesser Antilles with those in Central America. So I'll just briefly run through this. These are all the volcanoes in Central America that we just visited, and mostly the ones, right all through here. He basically came up with a way of trying to come up with the volume, the actual volume of each volcano. So he was actually pretty diligent in trying to come up with his numbers. And he actually went, in the Antilles, he went off the coast and measured the amount of tephra and ash layers and ashfall that fell into the ocean. So he measured that. So he came up with these numbers. And basically what you have in the Antilles is you've got a fairly slow moving plate here. It's moving to the west, but the faster moving North American plate and the South American plate, and they actually split right here in the Antilles. This is what we're talking about. So you end up with about a basically it's about the same subduction rate as we have off the coast of the Juan de Fuca plate. So I thought, okay, well, that makes sense, because that's what I'm trying to prove here. We got a slow subduction rate, and we don't have much volcanic activity. And this is just a side view of what's going on in the Lesser Antilles. Another shot of that, and they basically have a volcano every 40 kilometers. 19 volcanoes are active, with 5 that are very active. I'll talk about that. One of these you guys are probably familiar with was off the island of Martinique, which Mount Pelee erupted in 1902, same year as Santa Maria. 30,000 fatalities, and you probably heard that there's one survivor in town. Well, he turns out that he's fairly famous because Lugar Sabaris, he was basically incarcerated down in this hole down here in this jail, and he survived mainly because the reason he got incarcerated, but he was running around town telling everybody this volcano was going to go off, and they thought he was nuts, and so they put him in jail because they thought he was a danger to everybody. So he basically was put in this jail down there, and he survived the eruption that happened the next day. So he's there's quite a patronage on the webpage about this individual. But Mount Pelee is about to go off again. It just was recently upgraded, went from dormant to considered not a red level, but it's starting to heat up, and it's the first time it's shown any activities for the last since about the time GSOC was created. So about 80 years ago. The other one that's about to go off is just 2 islands south, and you'll see that the same thing. This erupted in 1902, the same time as Mount Pelee and the same time as Santa Maria. But its level is up to orange, and they basically have told the whole population. They haven't evacuated everybody, but this thing's about ready to go off. But the key thing with the subduction rate was these are where these two volcanoes are about to go off. This is Las Soufrières, and this is Mount Pelee there. But you can see here in Central America, you've got roughly the subduction rate at the Cocos Plate is about 5 inches a year, and this is about 3 times less. And basically you have almost double, triple, or about 7 times the amount of volume that's been put out. That's what these numbers are. In one instance, it's 12 times as much, and one 7 times as much. So it's kind of it's a rough estimation that the less, in my simple mind here, I said, okay, well, if you don't have much subduction, that the rate of subduction is low, then you don't get much production. So that's kind of what this paper says. And so I was leaning heavily on this until I got into the next piece of research here. And so I'm going to go up to where we're at now. And so the Cascade Volcanic Arc is roughly, it's about the same length as the Trans-Mexico one, and then which is about 1,200 kilometers, and then the Central America one is another 1,200 kilometers. And as I said, it's fairly slow, about an inch and a half a year. Fairly shallow subduction under here. It starts off fairly flat, and then it steepens. A lot of people nearby. And what O'Hare in this past year, 2020, said that you got 20 major vents and 4,000 minor ones. And now he's talking about all the stuff around, Mount Bachelor and Mount Tabor. All those things are included in this number 4,000. And that the volcanic arc is roughly about this 40 million years, which is when it was still the Farallon plate out there. And so basically that number, I didn't have that number, I'll have it later, but that's basically what the production rate is for the Lesser Antilles. So I thought, okay, well, that proves that you're not getting much production out of there. But again, hold on to that thought for a minute. Again, these are the Cascades, and most of you folks know about them. They go way up into Canada and head down into down by Lawson. And again, this is all fairly young, warm, non-altered basalt that's subducting under the western coast of North America. This is right off the USGS page that says these are all fairly high risk for eruption, and they go from right in here, and then you have lesser risk as you go down this list. In total, in my count, I had about 15 active volcanoes in that distance, and so it's roughly about 73 kilometers between volcanoes as compared to what we said earlier. This is a side view of what's going on, and we have a detached subduction zone down here that was there before the Silesia docked on here. I won't go into that. That's another talk, but that's a side view of Oregon. This is a view of the tomography of the subducting plate underneath the Cascades, as composed to the steepness of that's the Cascades, and this is Central America. You can see the difference in the dip of the subducting plate. Again, the question is what's going on here? And if you go back 150 years or so, I mean, you had Mount St. Helens had a minor one, Mount Rainier had a minor one, Lassen was somewhat moderate, and then Mount St. Helens, as you know. And then I talked to somebody at the USGS, and he says, you know, we generally view the Cascades as having eruption once every 50 years. Lassen was here in 1915. I would recommend you guys go visit this one. This is photos we took a few years ago. And it's definitely worthwhile visiting. It's very similar to Yellowstone in some respects. Mount St. Helens, you know about in terms of activity. That's a picture there. And then obviously this one is the one that took off in 1980. Here's I don't know if you folks had a chance to get to the Portland Art Museum, but this is these are all out of acrylic that this gentleman put together, these eruption sequence of Mount St. Helens in 1980. And then basically Mount Mazama, which basically is 7,700 years ago. And then what's the largest one in volcano? You guys can type it into the chat if you've got it. But this is a little bit surprising, and a lot of it has to do with the edifice building is strongly dependent on the chemistry. And this volcano was basically well, it's 75 miles long, 27 miles wide. It's mostly basalt. And here's a side view of it. So it's primarily basalt with some eruptions, some rhyolite and dacite that build that cone right there. So basically, the answer to that is basically Newberry, and that's roughly about 600,000 years ago, and it grew up to it was up to 14,000 feet until it had a major eruption about 7,500 years ago, 7,700,000 years ago, I should say. And it's considered a shield volcano. Is why it doesn't look like an edifice like the rest of the, you know, the Mount Hood and Mount Rainier and Mount Adams. Speaking of Rainier, this is considered a decade volcano because it's a large population is quite at risk with just the occurrence of a real minor eruption. Now, Sheila and I did a talk a couple years ago with about this concern about these lahars that are going to get generated off the top of Rainier. Here's Rainier, and basically you have these glaciers that run down here. But what these glaciers are gnawing away at is rock that's been completely hydrothermally altered by all this sulfur dioxide, and these rocks is just a pile of mud, really, or clay. So there's not much holding up the top of Mount Rainier, and the concern is all you do is get a fairly minor eruption, and then all this flank, this northern flank, mainly because the glaciers are on the north side of a volcano, this is all going to run down through Ording. So there's a real concern about there was something called the Osceola Mud Flow through here, and the Electra Mud Flow over by the Puyallup River. That would be the biggest risk. And talking to the people at the Cascade Volcano Observatory, they really are concerned about Rainier. This is that paper I talked about with Dan O'Neill, and all these little dots are these 4,000 volcanoes that he counted, and he basically had a fairly rigorous way of coming up with the volcano's volume. And this paper, as you can see, just came out a couple months ago. You can get that at the USGS or at Geology, GSA. This is again the basically number of events, and he basically maps them according to latitude, and you see this big batch down here is down by Newberry, and Newberry's got hundreds and hundreds and hundreds of little craters up around South Sister as well. So I tried to wrap everything up and kind of compare these three volcanic arcs. You got the Central America, Lesser Antilles, and the Cascades, and you got these characteristics about the different slabs of the characteristics of the subduction plate, and then you have this volcanic production rate. So I kind of at this point I wanted to rest my case and say, okay, scientifically, I think I proved the hypothesis that if you have a fast subduction rate, then you end up with a lot of volcanoes. But I kept digging, and I found this paper, which was quoted in the O'Hara paper, and basically this gentleman in Hildreth in 2007 says there's a lot of volume in the Cascades. In fact, this 6,400 cubic kilometers is on par with, it's quite a bit more than what Central America has, which is also quoted. So you can see this is kind of what I was drawing on is like the current history, and what I in my little short 72-year period, this is what I see, and this is kind of what I was leaning towards wanting to believe. But this is more the truth, is that over the years, over the last the Quaternary, roughly the last 2.5 million years, you have a lot more volcanic production in the Cascades as compared to the Central. So in a sense, my hypothesis kind of fell apart all of a sudden. So that's why I want to call it a work in progress. That's going to be it for my talk, but I have two little subjects I want to talk about. What I would need to do is if I want to do more research, I'm going to have to basically look at the time periods and the arc lengths, and then basically all I'm trying to say is my experience and seeing all the activity in Guatemala could be misleading me, is what I'm here to say. I do want to talk about a recent article that was in the Oregonian, and then I don't know if Scott Burns is on the Zoom call here, but I did wonder about this, and this stuff in the red oval is highlighted here, over here on the right, and maybe you can read this, but you can see where this gentleman said that the greatest risk in the Multnomah County area is not earthquakes, but it's volcanic. So he's calling this very high risk. It's FEMA that's calling it that. And you can't see it in the next column, but it talks about earthquakes as relatively high risk. And so the concern is that I thought this was kind of misinformation. Scott, are you on here? Could you kind of address this a little? So maybe Scott's not on here. He and I
he is on here, and I just saw him on mute.
I'm on here.
Go ahead, Scott.
So I talked about this the other day. And,
yeah.
It was a shocker. I remember when this came out, and I still think the earthquakes are the number one geodisaster that we have to be facing here. And all of our volcanoes that we have in the Portland area are all extinct. And we have Mount Hood, which is our closest volcano, but our biggest problem that we have up there is primarily lahars coming off of it and not ash that we have got. So for Multnomah County, how can it be very, very high risk? And so I don't know where he got this.
It's not possible that FEMA got wind of our boring volcanics, did they? And misinterpreted something. I mean, there was a little bit of murmuring by one geologist about the threat of boring volcanics. Maybe FEMA is misinterpreting that. So
I talked to John Major, who's at the CVO. He said he was going to dig into it. It was quite frankly, it was news to him, and he thought he would dig into it and see why FEMA announced this. I mean, he's concerned about this volcano, which is Mount St. Helens. In a sense, we do have a lot of local volcanic activity, because this dome, this is Mount St. Helens, and this dome, there's two of them here, have been growing quite extensively and quite vigorously since the eruption in 1980.
Bill, when
And
you hear back from FEMA, can you get back to us? I think we'd all be very curious.
Yeah, Scott and I will work on that. Okay.
Okay, good.
What this dome building is doing, which is, I would consider this, extremely active, and maybe this is what the FEMA article was referring to, but at the rate this dome is building in the next 50 years, it'll go back up to its previous height. So this is a picture of Portland down here just for scale. This was taken out of OPB presentation. This is a picture of the dome in terms of thermal activity. So I mean, you got volcanic activity right at the surface here. The other, I talked to another geologist down in Menlo Park, and he referred me to this diagram that Dan O'Hara put out, and this is all heat flow underneath the Cascades, and it was his bet. You can see this all tied with Newberry across here. The Newberry could be a candidate as well. The other thing that's in this vicinity is the bulge at South Sister, which is located roughly where this star is. You guys have heard about that, and here's a picture looking, looking from west to east, and this is Broken Top over here, and this is Bachelor, but you got North Sister and then South Sister right here. But it'd be in this area here. And basically this bulge began around 1998, and it continues to this day. They measure it every year. It's averaging roughly about an inch a year or so. In some years it doesn't move at all, but I just wanted to say that that's as far as I know in terms of volcanic activity in the Cascades. So with that, you can clear the screen and ask questions, Sheila.
Okay. Can everybody hear me? There
Yes.
were some questions that came in, and so let me get back to them. Okay. Going back to the beginning of the talk when you were talking about the tectonic plates and the Ponte Fuca breaking off from the old Farallon plate, the question came in: what happens to the spreading center, the Ponte Fuca, when the Ponte Fuca spreading center gets subducted under the continental edge?
Well, that's kind of what happened with the leading edge of the basically the when the Farallon plate came over here, the continental plate went over it, and it turned into a transform fault. Basically, this is going east-west, and then you see this action here along this boundary here is a transform fault, and so it ran over it. That's probably beyond the scope of this presentation, but truly what happened here is there's a spreading center here that we're talking about. What's the name of that plate, Scott?
Explorer.
Yeah, and we overran that spreading center, and that's basically where they say the Chalice volcanoes, volcanics came from, that are, up in northern Washington and Idaho. But basically, yeah, you end up with a gap in the subduction. You don't have a subduction area there. you know, I've got that on another talk. We can talk about that next time.
Well, basically the Sierra Nevadas, that's what happened in California with the San Andreas Fault. And so the Sierras have been eroding ever since. So, you know, the Cascades would shut down in that case if we totally overran the spreading center, or when we totally overrun it. And then we'll have another gold rush here.
Right.
So that brings the gold up to the surface. You know, I mean, eroding down the cones, the active cones gets you down to the Pluton where the gold is. So, but that's not for another few million years. So,
Yeah.
okay. Let's see. Somebody else asked, can you feel the rumble when you're on Fuego?
Yeah, that's a great question. The what was going on when we were up there? This thing was this thing would go off, and it would throw rocks over there, and you can see these are rocks that hit, and then they create these plumes of dust that blow. So that's kind of what's happening. These things throwing rocks out left and right here. And during that 2018 eruption, some of the rocks actually came all the way over to Acatenango, where I was. It's about a mile away. While I was up there, we could see, I don't have a good picture of it. Maybe I find here. Yeah, there's a group, there's just a saddle here between these two volcanoes, and a group of early hikers got in there, and they were walking over here on this ridge, and this thing let loose a whole bunch of rocks, and you know, all those hikers scattered like crazy. The thing is, you never know if those people got hit or not. I mean, how would you ever know? And I just thought it was kind of crazy to be over there. So it's off limits for very good reasons. So if you guys decide to go up there, I would just stay on Acatenango if it were my money. But to answer your question, this thing was going off like a cannon all night long, and some of the bigger eruptions would wake you up, and then you'd go back to sleep, you know, as long as the rock didn't hit you or something.
Okay, that's a pretty good answer. We also had a question about Lake Atitlan. How was it formed? Was it a blocked river valley, a caldera, or what?
Oh yeah, it's one of the biggest calderas in the world. Yeah.
Okay,
I should have said that. Yeah, it's a huge caldera.
So this cone is just kind of a resurgent cone, kind of like Mount Scott is to Crater Lake.
Yes.
So this is the caldera itself, then the large.
Yeah, and an interesting fact: there's absolutely no drainage for this lake. All right, so in 2010 they had a huge hurricane come through here, and the lake level rose like 10 feet, like overnight. So all the wharves, all the lakefront, all the infrastructure they had built up over the years, it was suddenly underwater. All right, so you know, we go back there every year, and we come up here and hang out, and so they've rebuilt in the last 10 years. They've rebuilt the infrastructure, but somebody was asking where the Mayan civilization was, and so somebody had the idea of going down into the lake here, and 180 feet down they found all this infrastructure that indicated that the Mayans had lived along the shoreline way back when. And then so this whole lake has risen you know, over the past 300 years, 180 feet roughly is what that analysis said.
Wow. Okay. Good. Thank you. And then the last question that I can see on here, let's see, there may be another one. Has there been any activity in the Newberry area that you're aware of?
No, Scott?
Oh,
And Scott wants to ask a question, so go take it away, Scott.
first of all, Bill, absolutely wonderful talk. I learned so much, and so thank you very much. I just, my mouth is watering of all these places I want to go and visit and see some of these volcanoes. You know, the volcanoes of Guatemala, I was expecting most of them to be andesite and dacite. But then the photo you had of your wife up at the top of Pacaya looked like basalt.
Yeah.
And so what's the makeup of most of the volcanoes that you were on, you know, volcanic rock-wise?
Well, I think there's a lot of bimodal stuff. That Suchitan is all bimodal. Rhyolite next to basalt. I mean, it's yeah, definitely mostly basaltic stuff, but you know, it does have some dacite and andesite to get those stratocones in there.
Yeah. But very interesting. Thank you.
Yeah, very good. Give him a hand here. Okay. That's it for the questions that I can see, but people are free to unmute themselves, or maybe, Carol, would you be able to unmute everybody? Maybe I can too. And people can ask questions directly. Also, feel free to stay on afterwards. And there were some people that had questions about Dogami, and I saw that Yume was here for part of the time. If she could answer them, that would be very helpful. I see she's not on anymore. Okay, well, anyway, we can, you know, feel free to stay on, but there may be people that have more questions for Bill. So ask away, folks.
What's the significance of bimodal volcanism? I know there's several cones in Oregon that are said to be bimodal, and I've heard that term come up frequently, and it seems to indicate something.
Yeah, I'll start, and then Scott, you can finish. But basically, when you have basically a magma chamber, Denny, it sits there for years and years and years, and you know, the silica, the felsic material moves to the top of the chamber, and then your denser stuff sinks to the bottom, and then when the magma column moves up into the when it's due to erupt, when the pressure gets lessened up above, you know, I think you end up with you know, I think you have a lower melting pressure or temperature with the basalt. So I think you end up with basalt coming out first, or you end up with fountaining and that, and then later on the rhyolite comes out. I could have that wrong, but Scott, could you help me there? You're on mute, Scott.
We can't hear you, Scott.
Yeah, Newberry Crater is the classic example of the bimodal volcano. And in fact, all of those volcanoes between Newberry and Burns, that whole high lava plains area, almost all of those are bimodal. First, you get the formation of the shield volcano, and then the last part you get the classic rhyolites coming out. And Newberry, I mean, we got the big obsidian flow right at the end, and then the formation of the caldera in that. And those were all very, very violent volcanoes. Then you have Glass Buttes, which is further down towards Burns, same thing. The last eruptions were the very silica-rich ones. And so we need a volcanologist to actually explain all of that. But I think it has to do with the material in the volcano, in the magma.
And I know it has a lot to do with basalt has got a lot lower melting temperature, Denny, and so you end up with that first. And because the rhyolite's a lot pastier and stickier, it tends to come out later. I don't know if you remember when we were over there in Idaho, but you look across the Snake River Plain, you could see, some of those buttes sticking up. Those are all rhyolitic, and everything else is basaltic. So, like Manan buttes and those buttes that stuck up over there by the Idaho National Engineering Lab, those are all rhyolitic. So those are pretty classic. And then, a lot of that bimodal volcanism we could see down there in Guatemala as well.
I'm thinking of
I
South,
can add something to this, but
Go ahead. No, go ahead, Denny, and then Sheila.
I was thinking of South Sister, which I think the big cone is mostly basaltic, isn't it? But then they've got those rhyolite domes down at the base of it, right up against it.
Right. Yeah, that would be pretty much the same scenario that Scott was talking about.
Mhm.
Yeah, go ahead, Sheila.
well, I was just going to say, when you've got a magma chamber and you've got maybe a caldera, you've got a silicic magma chamber there, then any new stuff coming up, which is basaltic, if it comes up from down deep, has to kind of go around it. So you'll find in an area with a collapsed caldera, you'll find the mafic stuff all the way around it, because it can't come up through it's more dense. It can't come up through the less dense stuff. So it kind of goes around it. So that's one reason why you see two kinds of magma in the same place, or two kinds of lava. The longer
Okay, that
it's
helps.
around, the more silicic it becomes, and then more explosive. But then any new stuff coming up kind of has to go around it, around the edges.
Thanks.
That was from Christensen's paper.
Okay.
Okay.
Yeah. Okay. Anybody else? Any other questions? I'm not seeing any. You've got some good comments that you should read, Bill,
Okay.
in the chat. Some good compliments and good comments. And I think with this, we'll close the meeting if there's any other questions.
Can I break in with a question real quick?
Sure.
So, Bill, there's a lot of papers that you cited in this talk. Is there a way to, without watching the thing again, to maybe get a listing of those papers?
Sure. Yeah, I can do that. How should I best do that, Sheila?
Go ahead and repeat what you were saying.
So the gentleman asked if I could provide a list of all the papers I cited.
You could send them to me, and I will talk to Paul, and we'll get them on the website. We could put a link. Paul, you might want to join in here, but I think that he can put a link to them in the article.
Why don't you set them up as a Google Doc and we can link them on the website or put it up on Facebook?
You could put it in the same article about his talk and add it
Yeah.
to that or something.
Is Carol writing up the article as she often does?
I hope so. I always look forward to
We'll
her.
let Carol Hassenberg speak for herself if
Yeah.
she is.
She's smiling.
I have been like sucked into the rabbit hole lately with the political stuff I've been doing. So I haven't done too much on that. And then there's a lot of field trip stuff coming up. So I really, I've kind of backed off from writing articles on all the different Zoom talks we've had because everyone can just look at the talk.
Well, that's a good point. Yeah.
If there's, I really enjoyed your talk, Bill. I was down in Nicaragua in 2006, but we were doing Engineers Without Borders things, and we were pretty busy, and there was so much pollution you could hardly see any of the volcanoes, which was really disappointing. But you know, I'm really interested in the topic, and I'm glad you took that on, because that it's important to know more than just the organ geology.
So
Scott, we
I
should
think
we should do a tour, man.
I think the thing that we can do to simplify it is just, if you will send it to me, Bill, then I will send it to Paul, and Paul can get it in on the website. And it'll
Yeah.
be under the article, or, you know, the little advertisement that we had for you.
Okay,
Okay?
sure. I'll do that
Sound
tomorrow.
okay, Larry? I guess Larry's not answering.
Yes, sorry, I was muted.
Okay, yeah.
All right.
Yes, that'd
We'll
be
do it, Larry.
perfect. Thank you.
Yeah, good. Also, you had a good diagram. I was going to ask you if I could borrow one.
Oh, yeah,
Here's
well,
like
you're
the
welcome
one
to
with
it. I can,
Silesia, the cross section showing Silesia. I've never found a good one. That was really good.
yeah, I mean, that whole thing about the clockwise rotation and just the offset of the Yellowstone hotspot, you know, well, you know, basically they're volcanic centers. I mean,
Mhm. Yeah,
and then it burns through, you know, the hotspot burns through the plate, so to speak. I mean,
yeah,
that's an amazing process. It's almost, I mean, Scott, that's almost, you know, graduate level, you know, geology to talk about the Yellowstone hotspot and what's going on in Southeast Oregon.
yeah. Well,
Fortunately, we've had some good graduate level speakers who can
Yeah.
weigh in on that.
But yeah, that picture does show a lot of it.
yeah. Well, good. Okay. So, if there's no further questions, we'll stop the recording here, and then